Hello everybody, we are Team Lagartos Velocidad Luz and we are now presenting you our final presentation of the Battery Paste project. We are Fernando, Lucero,
Oscar,
Jonathan,
First we have the agenda, which we have the objectives, the depth, the black and transparent box, the interrelationship, higher level and fast diagrams, the house of quality and the morphological chart, followed by the concept screening and concept scoring, product architecture, parametric design, failure modes and effect analysis, system and subsystem level modes, the DFA and DFM analysis, and the design of our prototype.
here is our objective, and this will be find the best fitted geometry, energy, power ratings, and most appropriate location due to the car energy requirements, and to come across to an alternative source of energy for a car interested mainly in the development of an alternative power source because of their cleanness and upgrading efficiency.
well, now we're going to talk about the depth. We have that what makes our project elemental for his car consists of the need of energy to fulfill a specific automobile, designing the best project schedule to accomplish the task list. We have contacting the best supplier of lithium batteries, and finally we have to reduce energy costs and the purchasing process.
Here we have the black box and transparent box. It shows the entrance and the deliver of the battery, which is deliver energy to the motor, and it makes the path between the subsystems and system of the battery that could be store energy from the brakes, or a proper response, a smooth response, and deliver energy to the motor.
Our product is a lithium battery, and it is related with the energy that it must be conservative, autonomous, and must have a good delivery rate. With environment, it is best in moderate rain, moderate humidity, and moderate temperature. The law standards, we found a certification ISO 6469 about the environment problems with the batteries. And the materials, well, it must be light, it is made of lithium, it must be waterproof, hard, and it must be safe. It always must be user-friendly and have a good charging time, so it can get a good relationship with the users. The higher level diagram or product again is the lithium battery. The user is the people living in Monterrey, 18 years or older. The main function is to deliver energy to the motor, and the battery acts on the pace car. Our final objective is to move the pace car. The fast diagram, again the main function is to deliver energy to the motor, and it has two sub-functions: to store energy and to deliver energy. To store energy, we take into account a good capability, a good travel range, a good consumption rate, and it must be rechargeable. To deliver energy, it must have a high lifespan, a good delivery rate, and a proper response. A proper response is a smooth response and a fast response. And we found out that to solve these sub-functions, we must have a good number of cells, it must be light, low noise, we must have a temperature control, a good battery type, and a good location.
So now we're going to start talking about defects and things that we have to improve, and other things that we must reduce. Well, talking about stored energy, we have that the strongest relationship is that it must be rechargeable. For the travel range, we have that the very important thing is that it has to have durability and to increase all the main functions about the weight and the delivery rate. Talking about the energy outputs, we have to reduce the most of as much as we can. And finally, we have with our test about the and we have that the VAD is the best for us.
And the problem here is how to energize the battery that energize the motor. We found many ways to do that, mechanical, electrical, chemical, and some miscellaneous like solar, aerobic, and piezoelectric. But the most important that we found was to charge the battery on house and energize the battery, and then it goes to the motor, or with a flywheel to the battery and it to a store, and it goes to the battery to deliver to the motor.
For the concept screening and the concept scoring, we took several technologies between batteries. So we had almost every one of the nickel family, also the lead-ion and the lead-acid battery. The lead-acid was our standard, was the one we consider as our zero first, and then we had the comparison between the energy density, the weight, the dimensions, and everything. So our best solution was the lead-ion battery, although it's the most expensive one. So we chose that one, although that.
Here we have our architecture diagram. Here we have the battery, and the main input will be to charge the battery, and it will be connecting some current to the terminals of the battery, and this we will accumulate energy, but with the same action we have some heat. And the other way is that we need to deliver energy to the motor. That would be accelerating pushing the accelerator pedal, and this will send a signal to the battery, and this one will deliver the energy to the motor. And the incidental interactions, the main one is the overheat. So we need to be sure that the battery has a secure circuit to prevent the overheat.
Now talking about design, we have that our battery structure, it must be modularized. The weight will be 11.2 kilos. Nominal voltage about 48 volts. Nominal capacity 20 amperes. Well, the maximum continuous discharge current will be 40 amperes. Maximum peak discharge current will be 60 amperes. Charging temperature will be plus 10 degrees or plus 50 degrees. The discharging temperature will be minus 20 degrees or plus 60 degrees. And well, the battery model will be a 12 volt one, and the model will be R1220 AC. The contact will be, as I said before, the BID America Corporation, and we have it here in Latin America, so here's the contact.
The design for robustness, we use the system of the lithium cell, and the product is our lithium battery. The subsystems are the thin plates, the lithium oxide on a carbon conductive polymer, and the microhalos and the motor. We found out that the main problems are in the heat that is produced. That's why it's good to have a good circuit for safety. But here we can see in our RPMs that the main problems are when the battery leaks, or when there's a fracture or too much fatigue, and in extreme circumstances, the ignition or the explosion of the battery, which are solved with a good detection method. And so we need to check and develop a safety procedure, and we need also to have a cool down system, a very good cool down system, so the overheat doesn't get very high. And also discharge and overcurrent are problems that we need to work on, along with corrosion or break of some parts. But as the main thing is to have a good safety system and a good cooling down system.
And now the problem is how can we come into a decision of a battery, we made some mathematical models to help us to select one of the old batteries. The most important things we found was the energy cost and the power density. Based on power of the cell times the cells required over the volume of the total battery.
For the design for assembly and the design for manufacture, we based our design of already existing models, which are the Somolitomo Electric Industries Battery Pack and the Nissan Leaf Battery Pack, which mainly is the cover, an enclosure, plastic enclosure that assures the temperature and that the battery is going to stay rigid and robust on the car. And our solution is like the simplest one, but it's almost the best one. So we thought that the battery should stay on this kind of enclosure. And here we have a little diagram that my companion is going to explain a little better.
So here we have our final prototype. This would be the battery pack. It would be a base, a cap, and here the container where we are going to put all 7 batteries interconnected. And we also we consider some space in here so we can put some air intakes. So we ventilate the battery pack so it does not overheat. Well, thank you very much. This is the end of our presentation, and that's it.